We have an equation with some rational expressions, which means we definitely need some at least common denominator. We're going to always start these problems by looking at these denominators, and we're looking for factoring if there's any factoring to do. This guy over here has no factoring whatsoever, so I'll leave him alone. But this second guy, I can pull out a common factor of x, giving me a 3x on top and an x times x plus 4 on the bottom. Now, some of you might notice a couple things you could do differently at this point exactly. Oh, this is going to be an interesting one. Okay, let's see what happens. But I'm going to treat this the way I treat all of them. We're going to find that LCD, multiply through by the LCD, and see what happens. So this denominator has an x plus 4, so I'll throw that x plus 4 down. And this denominator has an x. There's no plain old x here yet, so I'll throw that in there. It has an x plus 4. It's got an x plus 4. Life is good. So what I'm going to do next is write down what my thought is. So this is not something I typically write down. It's just my thought. I think about this part of the equation, and I think about multiplying it by this LCD, and I think about what would cancel and what would be left behind. So what would cancel is if I were to multiply it by x times x plus 4, these would cancel. So what I would write down is the 3 is left behind and the x is left behind. For this guy, if I multiply this by the LCD, my thought would be, what is this thing that's there multiplied by the LCD? What cancels and what's left behind? These x's cancel, these cancel. What's left behind is another 3x. That's why I was making that face in the beginning, because we get 3x equals 3x. And if you're going to solve this, it's a weird looking equation. This shouldn't really happen on the test or quiz, but you've seen this in Algebra 1. So what happens is we want to get all the x's to one side. So I'll subtract 3x from both sides. And I get a statement 0 equals 0, and all the x's are gone. And you might, if you think back to Algebra 1 and think about what happens when all your x's disappear, you either have a true statement or a false statement. This is a true statement. 0 does equal 0, which means this solution is all real numbers. Anything will work in this, except for one thing, actually. You can't actually let x equal 0, and x cannot equal -4. Because these numbers would make the denominator 0. That's a trickier problem than it needs to be. That wouldn't happen on the test or the quiz. But the process that I illustrated, finding the LCD, getting things to cancel, and solving what's left, hopefully those steps make sense to you. The other details are really for like another time. They're not for right now. So good luck with that. Sorry for the confusion, and let's try the next one, see if that goes a little bit better. Bye.